Okay, ready, set, go. Let's see, you have homework due tonight, and then quizzes are due Monday. And then Monday, remember, is a review day. So the review assignment is up in Edfinity. You can work on that as you wish. It's due Wednesday on the exam day. It counts as a regular homework grade. So that's up there, and you can work on that whenever you want. If you come Monday with questions, that's all I'm going to do Monday is answer questions about that review assignment.
Say, are we going to have a class on Monday?
Yeah, so class Monday, I'll answer any questions you have from that Edfinity review assignment. And then Wednesday, we're gonna do an online midterm. It's gonna have two parts. One part that happens in Gradescope. I changed my mind about how it's gonna go. One part that happens in Gradescope, and that will have to happen during class time. So you'll have 1 hour to do the Gradescope part during class time from 12:30 to 1:45, okay? And then the second part will happen on Edfinity, and that can happen anytime Wednesday. Okay, so you'll have 1 hour for the part on Gradescope, 1 hour for the part on Infinity. The Gradescope portion must be done during class time from 12:30 to 1:45. And then the Edfinity part can be done anytime Wednesday. But once you start, you'll have 1 hour to finish the Edfinity part. Kind of like with your D2L quizzes, you know how when you start, you have 30 minutes to finish them. So that will happen.
How many questions are going to be on this?
It's, on the Edfinity part, I don't have the exact numbers. It'll be something like 5 and 10.
Oh, okay. I was like,
Yeah, it's not going to be.
And how many the
Probably around 5 on the Gradescope part and around 10 on the Affinity part. And some of the Affinity will be multiple choice, some will be enter your answer and it'll check for you.
it is your partial.
For the Gradescope part, there's partial credit. Yep. For the Affinity part.
Infinity, like it's just going to be high, right? Yeah.
Yep. Yep. No. It'll be one try.
On each problem.
One try. Yeah.
It's not
Affinity
gonna be
will
right
just
or
be
wrong.
one try. Yes.
Oh, the second you answer.
Yes.
Oh,
You'll do the whole thing and submit at the very end.
so
Oh,
it's not
okay.
like the homework.
So it's not like a homework Affinity where you can keep trying over and over again. No, it'll be just the one try. Yeah, just like a regular test.
Does that have time?
It will, yes. Oh, they'll each have a 1 hour time limit. Yep.
I mean, it's open.
Okay, so today we're gonna do the last little bit of what happens in the homework, and this is called logarithmic differentiation. So that's what we've got left to do today, is logarithmic differentiation. Okay, so we could compute the derivative of this function, x cubed minus 1 to the 4th times the square root of 3x minus 1 over x squared plus 4, using all the rules we already know, right? We could use the quotient rule because it's divided, the product rule because there's a product in the numerator, and the chain rule, right? Every time we take the derivative of stuff to a power. And so we could, but it would be long, tedious, it would be really, really obnoxious. And so what we do is we use this technique called logarithmic differentiation. And when we use logarithmic differentiation, what it does is make the piece you're taking the derivative of a lot easier, okay? So here's how logarithmic differentiation works. It says step 1, take the natural log of both sides. So here's my equation, and I'm going to take the natural log of both sides. Okay, so I'm going to take the natural log of both sides of that equation. So when I take the derivative, yeah, I'm not at that point yet, though. I'm going to do some of that before I take the derivative. But when I take the derivative, ideally, this is supposed to make things easier, right? And so I want you to see if you can remember your rules about logarithms. Do you remember the rules about logarithms? If there's stuff inside it, can we expand it somehow? What do the rules of logarithms say? So let's go, let's take a detour. Yes, that's a good one. So if you have the natural log of a divided by b, it's, what'd you say, Adrian? ln a minus ln b. That's a good one. Do you guys know another one? Yeah, if you multiply, what do you do with the logs? Add them up, yep. Okay, and then there's one more rule. Remember this one? Yeah, you can bring that exponent into the front, right? So these are the three rules about natural logs that you used in, your previous co-ed algebras and pre-calculuses. If you have two things divided inside the natural log, you can write it as two natural logs with subtraction. If you have two things multiplied, you can write it as two natural logs with addition. And if you have an exponent, you can bring it in front and make it a coefficient. Okay, so let's see if we can use these rules to simplify that natural log that we had on the right-hand side. Okay, let's see if we can use these rules to simplify that natural log that we have on the right-hand side. What you might notice is that we have that product here. So we should be able to add these two natural logs together, right? And then we have a quotient. So we're going to subtract that guy. So I'm going to do this in a couple steps. I'm going to start by saying natural log x cubed minus 1 to the fourth, natural log square root 3x minus 1 minus natural log x squared plus 4. So I just used the first two rules where if they're multiplied, it turns into addition. If they're divided, it turns into subtraction. Okay, the last thing I'm going to do is use that exponent rule, right? And the exponent rule said you can take exponents and turn them into, put them in front, make them coefficients in the front, right? Let's talk about what an exponent is. This 4 is an exponent. This cube is not. How come? Yeah, the 4 goes on everything inside here, right? The cube does not. So this 4, because it goes on everybody inside the ln, can come in the front as a coefficient. This 3, because it's not on the whole term, cannot. Okay, what's the exponent in this second term? 1/2. Remember, square root is the same as 1/2. So I'm going to take this 1/2 in the front. How about this third term? 1. Yeah, this third term doesn't have any exponents, right? You can't bring that 2 in front because it's not raised to the whole expression.
The second one.
The second one is 1/2. Yep. The first one is 4. I'm going to bring that in front. The second one is 1/2 because remember, square root is the same as raising something to the 1/2. And the third one gets nothing. So I started with something that looked really yucky. I took the natural log of both sides and I expanded the right-hand side to make it be something that seems a lot easier to take the derivative of, right? I don't need any product rules now. I don't need any quotient rules now, right? Like I got rid of all that annoying stuff. Okay, so step 2 says, differentiate implicitly with respect to x. Yeah, so differentiate implicitly. What's the derivative of natural log of y? 1 over y dy dx. Anytime you take the derivative of y, you need to stick that dy dx in there. Okay. 4 times. What's the derivative of natural log of x cubed minus 1?
3x squared.
Yeah, 1 over x cubed minus 1 times 3x squared. You could put the 3x squared in the numerator, right? Okay, plus 1/2 derivative of 3x minus 1. I'm sorry, natural log of 3x minus 1. 1 over 3x minus 1 times 3, okay, minus derivative of natural log of x squared minus 4. Oh, it was plus 4. 1 over x squared plus 4 times 2x. Okay, I'm going to write this down nicer so we can see it better. 1 over y dy dx is the 4 and the 3x squared are in the numerator. That makes 12x squared over x cubed minus 1. Plus, I have a 3 in the numerator and a 2 in the denominator. Minus, I have a 2x in the numerator and an x squared plus 4 in the denominator. Okay, so now it says, remember, our goal was to find f prime of x, right? Or the derivative. So now I need to find f prime of x or dy dx. Remember, those are the same. F prime of x is the same as dy dx. How do you get dy dx by itself? What do you do to get rid of that 1 over y? Multiply by y, right? So dy dx is y times all that stuff. I'm gonna write down all that stuff again. 12x squared over x cubed minus 1 plus 3 over 2 times 3x minus 1 minus 2x over x squared plus 4. So we could be done, right? But the function that we started with was explicitly in terms of x, right? It said y equals something with only x in it. Compared to the implicit differentiation we did all day Monday, right? Those had like x's and y's all mixed together. We couldn't get y by itself. So ideally, we would like our derivative to only have x's in it. So how do you think I can get rid of this y? What could I replace this y with in my derivative? The original equation. I could go way back up here to the original equation that I started with and replace that for my y. So I'm going to take this piece, this x cubed minus 1 to the 4th, square root 3x minus 1, x squared plus 4, and replace it with this y. So dy dx, or f prime of x, is going to be that whole fraction times this whole derivative. This was x cubed minus 1 to the 4th, square root 3x minus 1, x squared plus 4. Right here. So I did the derivative of the natural logs. So the derivative of natural log of something is 1 over something times the derivative of the inside. So derivative of natural log of y is 1 over y dy dx. Derivative of natural log of x cubed minus 1 is 1 over x cubed minus 1 times 3x squared, because it's the derivative of the inside. Yeah, same here. Derivative of 3x, natural log 3x minus 1 is 1 over 3x minus 1 times 3, derivative of the inside. Yeah, so that's that rule that we just used, was the derivative of natural log of u is 1 over u times the derivative of u, whatever the inside stuff is. Okay, I have one for you guys to try. Here's yours. So I want you to just take like 2 minutes and try to do step 1. What was step 1?
It was.
Yeah, take the natural log and expand it, right? So I want you to take 2 minutes and just do the rule part. Natural log of y is natural log of this stuff. So just tell me what this is going to look like expanded. I'm going to give you a hint. There should be 3 natural logs. Okay, so try to expand that. Remember, if it's multiplied in the numerator, it's a plus. If it's divided in the denominator, it's a minus, right? When they're multiplied together in the numerator, it's a plus. If it's divided in the denominator, it's a minus. So when you expand these 3 natural logs, how many positive terms should you have and how many negative terms should you have?
What made it 2,000?
No.
No.
How many are in the denominator? 2. So as you get 2 negatives, because each denominator term gets a negative, and one positive because there's one in the numerator. You have to write very tiny. Yeah, you can do it that way. Make sure you put this and square plus 3 in parentheses. That will help them. Great. Perfect. No, that's an X. Yeah. When you bring it in front system. There's an X.
That's right, that's right, that's right, that's right, that's right.
Oh, I think that. Yeah,
Yeah.
but that's still.
Yeah.
multiplied by.
But if it's in the denominator, it's gonna get a negative. Yeah, because it'll have negative like parentheses with a plus in between. And so then the negative would distribute.
So if it's in the denominator, it's a negative.
If it's in the numerator, positive.
Got it.
See, we did that in pre-calc. That's why you know those rules.
I don't really remember anything from that, so.
You're doing great so far. I would distribute that negative. Oh, this might need something inside. Oh, yeah, so just put an X inside.
And then I distribute the negative out.
And then distribute the negative, yep.
Could do like that.
Yeah, that's right. Great. Okay, how's it going? I told you we should have one positive term and two negative terms. The two negative terms come from the denominator. If you go slowly and think about why it works, let me go back up to my rule list. If I go back up to my rule list and I do this example. A over B times C. Yeah, this would be natural log of A minus natural log of B times C, right? Natural log of A minus, what do you do with B times C? You add, but do you see that that minus goes with both of those guys? So natural log of A minus natural log of B minus natural log of C. So we can sort of extend these two rules and say denominator negative, numerator positive. So if there's a term in the denominator, you make it a negative natural log or log. If there's a term in the numerator, you make it a positive. Okay, so let's go down here. I think everyone was pretty close to this answer. Okay, so we broke it up into three pieces, and the three pieces were natural log cube root x plus 7 minus natural log x to the 4th minus natural log x squared plus 3 to the x. Okay, and then did you do anything else? Yeah, let's bring those exponents in the front. What exponent does this first guy have? 1/3, perfect. 1/3 x plus 7 minus, what's that guy got? 4 minus, what's the exponent of this guy? X. Okay, that was step number 1, right? What does step number 2 say to do? Take the derivative. Yeah, okay. The first derivative is easy. Yeah. Second derivative, still pretty easy. Yeah. Third derivative, still pretty easy, right? This guy, he's not as easy anymore. How come? There's an X in the front. You need the product rule, right? I know. When you take the derivative of this guy at the end, you need the product rule. Here's my first term X. Here's my second term natural log. Be careful. Make sure you put some parentheses when you take that derivative because you have a negative there. Okay. All right. So take, what do you think? 3 minutes? 5 minutes. Take some minutes and take the derivative of that guy. I'm going to pause the recording. Okay, here we go. What's the derivative of the left-hand side? Yeah, 1 over y dy dx equals 1/3 times derivative of natural log of x plus 7. 1 over x plus 7, whoops, times 1, right? Because the derivative of x plus 7 is 1. Okay, minus 4 times, what's the derivative of natural log of x? 1 over x minus, yeah, times 1, good. And this one is that product rule that we just did, right? Derivative of the first is 1, leave the second alone. Notice those big brackets, right? I have those big brackets because I want both pieces of this product rule to get subtracted in the end. Plus x times 1 over x squared plus 3 times 2x. Okay, I'm going to do a little bit of simplifying. This is 1 on the numerator and then 3x plus 7 in the denominator. This is 4 in the numerator, x in the denominator. Both of these guys are going to be minus. That's going to get distributed. Both of these guys are going to be minus natural log x squared plus 3 minus. This has x squared plus 3 in the denominator and x times 2x or 2x squared in the numerator. That's the derivative of the inside, derivative of the x squared plus 3. Because when I do the product rule, I need the derivative of natural log of x squared plus 3 is 1 over x squared plus 3 times the derivative of the inside.
We use the chain rule.
We use the chain rule, yep, inside the product rule. Okay, I have one more step to do. What is it? Yeah, move that y to the other side, right? So dy dx, I'm not going to write it twice. I'm going to write it once. So I'm going to put this y here, put this y here, put this guy in a big bracket. And so I'm going to say dy dx is y, which was that whole big thing, times this guy. And I got to write that whole big thing, which was what? Cube root x plus 7, x to the 4th, and then x squared plus 3 to the x. Sounds like we're trying to get in. If we were on the ceiling, I'd be nervous, but we're not on the, there's another floor above us, so we're fine. I guess if it caves in on them, it's gonna get us too, right? It's gonna be fine. Everything's fine. There's nothing to see here. Okay, I am ready for, no, I'm not. Don't tell me yet because I'm not ready. I am ready for, now I am, Affinity homework questions. Yeah, write it down. I'm not, I don't have it open yet anyways.
All right, that sounds.
I have a question.
We do have a-
11.
Specific question.
Okay.
It's, I was trying to use the chain. I'm trying to remember. I was trying to use the chain rule with the square root,
Uh-huh.
and it like instead of doing a fraction times this times another number, it may be like put the number that was on the inside on top as a numerator.
Oh, it made you. Did it, I think
I
if you,
got different answers when I tested it.
it should work either way, as long as you make sure that you, when you use it on the square root, you make that new exponent a -1/2.
Okay,
Because when you do a square root, like if you're doing square root of 2x plus 5, that's gonna be 2x plus 5 to the 1/2. So when you bring it in front, then the new exponent is gonna be -1/2 times 2. So just make sure you don't forget to use that
I think,
-1/2. It should work out.
the answer wanted me to put something.
It wanted you to put like,
Put in.
yeah, I mean, it could be this. These are the same.
The problem again, see what it
Yeah,
wanted me to
if you
do.
find it again, you can send me an email from the problem and I can like
Okay.
check it out too. Okay, I heard 11, 12, 6, 13, 7, 5, and what? Like the whole assignment, basically, that's what just happened. Okay, let me start again. 1, 10, 5, 1, 5. Did somebody say 6? Nobody said 6. Somebody said 6. 1, 5, 6, 10,
11, 12.
11, 12. 7, 1, 5, 6, 7, 11, 12. Is that what just happened? And 13? Is that what you just said? Do them all. 13. 10, yeah. 1, 5, 6, 7, 10, 11, 12, 13. Is that what happened? Okay. I feel like we did 13 on Wednesday. Yeah?
Remember doing
Go back to the recording. We did 13 on Wednesday. Take that off the list. 1, 5, 6, 7, 10, 11, 12. Yes? It's gonna be a long day. Okay, let me see if I can do them all. We got so much time. I can't even like get it to make a new page for me. 1, 5, 6, 7, 10, 11, 12. Here. Okay, I gotta get that stupid snipper out.
Do you suggest subscribing to the like help me with this thing if we're stuck with like one of the problems?
I suggest you send me an email first. There's like a button up there that says send me an email. Yeah. And if that, I mean, that should work out, especially if it's early in the week, like if you send it at 7 o'clock tonight. But I don't think if you subscribe, you're gonna get it back from that fast from them either, so. Yeah. Snip. Open. New. Okay, my husband says when I do this, it should automatically copy it to the clipboard. It does. Sometimes he knows what he's doing. 1, 5. Maybe. I'll put it at the end. Some of them might be fast. We'll see. 6. Oh. 7. 10, 11, 12. It's a good thing I have a good memory. I'm gonna make Jake do number 10. Jake and I did number 10 on Wednesday. If you come to the AEC, I stay there till 3 o'clock on Wednesdays and Fridays. It's like just a barrel of fun in there. I don't know, maybe Jake and Shruti will say no. You guys are done your homework already. Okay. All right, let's do it. 1. Oh my gosh. 1. Okay, 1 says calculate g of b and g prime of b, where g is the inverse of this function when b is 4. So remember, inverses reverse the x's and the y's. So if 4 is the x in my inverse function, then it's the y in my original function. Okay, if 4 is the x value of my inverse, then it's the y of my original function. So to find g of 4, I'm going to solve this equation. 4 equals x squared plus 6x to the 1/2. And I'm going to solve that equation in Desmos. I'm just going to solve that in Desmos.
Are we gonna be able to use Desmos on our exam?
Yeah.
Okay.
Yep, absolutely. Okay, so I'm going to solve this guy in Desmos. I need to make that 16. What number makes that 16? 2, x equals 2. You solve it in Desmos. I did it in Desmos. I did this problem earlier for my online class. So this is the point 2, 4. So g of 4 is 2. Okay. Okay. Remember that the rule for inverses is 1 over f prime of g of x. This is how you find the derivative of an inverse. That was the rule from Wednesday. The derivative of an inverse is 1 over f prime g of x. So to find g prime of 4, I need to do 1 over f prime of g of 4. But remember, g of 4, we just found out was 2. So I need to do 1 over f prime of 2. Here's my function f. I need f prime of 2. So I'm going to take the derivative of f. What's the derivative of f? One half x squared plus 6x to the negative 1/2 times plus 6. Perfect. Okay, I need to find f prime of 2. So I'm going to take 2 and I'm going to plug it into that guy to find f prime of 2.
This was one of the problems where
It wanted you to have that other number.
6 on the top as a numerator.
Yeah, you could do that if you want to, but you don't have to. You just got to get this number, right? So put this number in your calculator. This is 10 over 2 is 5 over 4. I think. Put that in your calculator. I think you get 5 over 4. So I have 1 over 5 over 4, which is the same as 4 over 5. Yeah, just plug this in your calculator. Whatever you get, you plug this in your calculator. Yeah, if we have time at the end. Yep. Okay, 5. Oh, 5 says the derivative of tangent inverse. What was the derivative of tangent inverse? Tangent inverse of u was 1 over
X squared plus 1.
u squared plus 1 times the derivative of u. Okay, so remember, because the stuff inside the tangent is not just an x, I'm going to put 1 over all that stuff squared plus 1 times the derivative of all that stuff. So this is going to be 1 over square root of 8x squared minus 1 squared plus 1. That's this first part, the u squared plus 1 part, times the derivative of the inside. Square root of 8x squared plus 1 is really the same as 8x squared minus 1 to the 1/2. So to take the derivative of the inside, I need to use the chain rule. 1/2 8x squared minus 1 to the negative 1/2 times 16x. Perfect. I would type it in just like that if it were me.
Inside for the first one, 1/8 8x squared plus 1.
So we just,
I mean, you need parentheses inside the square like that.
Okay.
Yeah. You could simplify if you want to, but I wouldn't.
so that entire equation is the whole answer?
Yeah.
All right. And we don't need parentheses around the entire first fraction?
No, because it's a fraction, so it automatically sort of has its own parentheses
Okay,
built
that
in.
makes sense.
It doesn't hurt, like you could put parentheses around it like this, but you don't have to. A fraction has its own parentheses built into it.
Understood.
Okay, 6. Oh, dun, dun, dun. Which rule do I need for this guy? The product rule, yeah? And the sign inverse, yeah? I need the product rule because I have a whole bunch of stuff with X times a whole bunch of stuff with X. Before I start, I'm gonna rewrite this guy. I'm gonna write him as 1 minus X squared to the 1/2 times sine inverse X. So my first function is the 1 minus X squared to the 1/2. And my second function is the sine inverse of X. The product rule says derivative of the first, 1/2, 1 minus X squared to the negative 1/2 times negative 2X. Okay. Times the second, just leave them alone. Plus first, 1 minus X squared to the 1/2 times the derivative of the second. What's the derivative of sine inverse of X? 1 over the square root. I think it's the other way. 1 minus X squared. Who's got their rule up? Does it go X squared minus 1 down here or 1 minus X squared?
1 minus X squared.
1 minus X squared. You could simplify if you want to, because I think these two are the same. This guy and this guy are the same, right? I have a square root of 1 minus X squared here and a square root of 1 minus X squared there. So if you wanted to, you could simplify those and just write a 1, but you don't have to. You could leave it just like it is. If it's easier, you could, cancel these two out and just put plus 1 at the end. But don't forget to use the product rule.
So it's like 1 minus X sine inverse of X divided by square root of 1 minus X squared.
Yeah, that's the same.
Okay. So I put in that instead of wrong.
It did. I don't believe it. Okay, which number was this? 6. What is it? What's it saying here? Oh, nothing. What is it? Times 1 over square root. Oh, it won't take that. That's sad. 1 minus X squared. Wait, I missed something. Here I need sine inverse, right?
Yeah.
I have it right now. Okay, let's see. Maybe it didn't like the way you typed in sine inverse.
Yeah, because I would do like I put in sine.
And then raise to the negative 1. Yeah, so it looks like it wants you to use that arc sign instead of sine inverse. Yeah, so try that. Okay, onward. Use implicit differentiation to find dy dx. This is 7. What do I need for this right-hand side? Product rule, great. And then for the left-hand side, I need the chain rule, yeah? So derivative of x squared plus y squared to the second is 2 times x squared plus y squared to the first times the derivative of the inside, 2x plus 2y dy dx. Perfect, equals. On the right-hand side, I need the product rule. Derivative of 10x is 10 times y squared plus 10x times the derivative of y squared, 2y dy dx. If you want to, just be careful not to confuse which ones are y's and which ones are y primes. Yeah. Okay, I need the dy dx terms on the left and the non-dy dx terms on the right. The problem is that right now this 2 times x squared plus y squared is attached to both kinds of terms. It's attached to a non-dy dx term and a dy dx term. So I have to distribute this guy here before I can break it up. So I'm going to take a step and distribute that guy. So I'm going to take this guy and put him here and here. Okay. So 2 times 2x makes 4x times x squared plus y squared. And then 2 times 2y makes 4y times x squared plus y squared dy dx equals. The right-hand side didn't change at all. 10y squared plus, I'm going to multiply those together. 10 times 2 makes 20xy. Okay, I need the 2 dy dx terms on the left and the 2 non-dy dx terms on the right. So I'm going to subtract the 4x times x squared plus y squared to the right. And I'm going to subtract the 20xy dy dx to the left. So the left-hand side is going to still have that 4y term. And then I subtracted this guy. So minus 20xy dy dx equals. The right side still had that 10y squared. And I subtracted that guy, 4x times x squared plus y squared. Okay, factor out my dy dx. I have 4y times x squared plus y squared minus 20x. And then the last step is to divide by all that gobbledygook, everything that's inside there, divide him. So the numerator looks like the right-hand side, 10y squared minus 4x times x squared plus y squared over all of that stuff, 4y times x squared plus y squared minus 20x. Dang. Thank you. Okay. 10. 10 says 25 plus 9f of x plus x squared times f of x cubed equals 0. F of -4 is -1. Find f prime of -4. So this is kind of like implicit differentiation because f of x is some function defined in terms of x, which we don't know. What do I need to use for this third term over here? Product rule. Okay, derivative of 25, 0. Derivative of 9f of x is 9f prime of x. Perfect. And then I'm going to use the product rule here. So my first function is x squared. My second function is f of x cubed. Derivative of x squared is 2x. Leave the second function alone. Plus, leave the first function alone, x squared. Derivative of something cubed is something 3 times something squared times what goes at the end here? The derivative of the inside, yeah, f prime of x equals 0. Because this thing here, you could kind of think of it as x squared times y cubed. So I did 2x times y cubed plus x squared times 3y squared dy dx, right? That's where that implicit differentiation comes in. Okay, now I'm going to plug in my number, and I'm plugging in -4 for all the x's. So -4 here, -4 here, -4 here, -4 here, -4 here, -4 there. So every x gets a -4. Okay, now I know that all the f of -4s are -1. So this guy here is a -1. But these other two guys are f primes, right? So I can't make them -1s. They're going to stay there. Okay, so I have 9f prime of -4 plus 2 times -4 times -1 cubed plus -4 squared times 3 times -4 squared times f prime of -4 equals 0. Okay, now I've got a bunch of numbers. This number, put that number in your calculator. 2 times -4 times -1 cubed. +8? Yeah, because I have 1 negative there and then 3 more negatives there. So 4 negatives makes a +8. Okay, plus. And then this one is going to be positive again. And this is 16, 16, and 3. It's a really big number. No, 16 times 16 times 3. So what's 16 times 16 is 256 times 3, brace me, is 768. It's probably wrong.
Is right.
Yeah. We should check these numbers. They feel big to me. X squared, 3f of x squared. Yeah. Look, this was not a, this is a, I did bad here. This is I forgot the f here. F of -4. So this should be a green one. You see how I forgot the f right there? When I brought it down, that should be an f. So this should be a -1. So that number is too big. It's a lot easier now though. 48. Yeah, we're trying to find f prime of -4, right? That was our goal, find f prime of -4. So right now I have 9 f prime of -4s plus 48 f prime of -4s makes how many? 9 plus 48 makes 57 f prime of -4s. So I combined these two guys together because they're both like 9x's plus 48x's. Plus 8 equals 0. If I want to solve for f prime of -4, I'm going to subtract 8 and divide by 57. What number was that? I don't know, 10. -8 over 57. Yes. Your numbers are going to be different though. So, yeah. Okay. I have 20 more minutes. I only have 2 more problems, 3 maybe. I can make it. This is not a Friday afternoon homework. This is like a Tuesday morning homework, I feel like. Okay, use implicit differentiation to do this one. Okay, this one's easier than the last one, I think. This is 11. What do I need here? I need that product rule in the middle again. You see that? Okay, the derivative of 3x squared is 6x plus, I'm using the product rule on the middle here. Derivative of the first, 9x squared times the second plus first times the derivative of the second, dy dx. Minus the derivative of 2y to the fourth is 8y to the third, dy dx, good. Equals 0, because the derivative of 28 makes 0. Okay, I got to get dy dx on the left and non-dy dx on the right. So I'm going to move this guy and this guy to the right by subtracting them. So the left looks like 3x cubed dy dx minus 8y cubed dy dx equals negative 6x minus 9x squared y. Factor out dy dx, perfect. 3x cubed minus 8y cubed. And then divide by all the gobbledygook. So this whole thing, 3x cubed minus 8y cubed goes in the denominator. So that's my dy dx. That was part 1. Yeah, part 2 would be the slope of the tangent line. To find the slope, you just plug 2 in for x and 2 in for y. So m is negative 6 times 2 minus 9 times 2 squared times 2 over 3 times 2 cubed minus 8 times 2 cubed. Now I'm gonna have to think hard. Negative 12. Let's see, I'm gonna do the bottom one first. Negative 40. What's the matter?
I did this like 10 times and couldn't get
You did it 10 times and you couldn't get the answer? You should send me an email before you do anything 10 times. Like after like the 8th time, be like, forget it, I'm just sending her an email.
How do you make it to the 8th time and not give up?
I mean, that's what makes a good, like, persistent growth mindset student, right? Sometimes I get emails and people have tried like 49 times. Like, seriously. Okay, negative 12. Wait, what's this? This is 8 times 9 is 72, negative 84. So I'm going with, I can divide that by 4. 21 over 10. Are your numbers the same as mine?
Unfortunately, no.
Yeah, that's too
Mine,
bad.
I think was instead of your 8x, I had like 12x. And at
Okay,
the bottom there, everything else was the same.
everything
I got
else is
negative 1 for it.
it's same now.
And it's not. supposed to be there.
I'll come help you in a second. Okay, so that's my slope, right? It says for part C, the equation of the line. So my slope is 21 over 10, and my point is 2, 2. The equation of the line is going to look like y minus 2 is m, 21 over 10 times x minus 2. Yeah. Distribute your 21 over 10 and then add 2. So y is 21 over 10x minus 42 over 10 plus 2 is plus 20 over 10. So minus 22 over 10. I don't know if that's right. You should check that number. I make no claims that that last number is right. Do 21 over 10 times negative 2 plus 2. That'll get you your number there. Okay, 12. Use implicit differentiation to find the equation of the tangent line. Basically, I gotta do everything I did last time, right? Here's a hint I'm gonna give you. And I'm gonna say, if you distribute first, then you don't need the product rule anymore. Yeah, if you distribute first, then you won't need the product rule anymore. So if you take this guy and write him as y to the 4th minus 4y squared is x to the 4th minus 5x squared. You see how I don't need any more product rules and my life is way easier than it was before? Okay, derivative of y to the 4th, 4y cubed dy dx minus 8y dy dx equals 4x to the third minus 10x. Okay, I need it at 0, -2. So I can plug in 0 for x and -2 for y. And I can do that now if I want to, right? I don't need to solve for dy dx first. You can plug in the numbers whenever you want. So 4 times -2 cubed dy dx minus 8 times -2 dy dx is 4 times 0 cubed minus 10 times 0. What do you get on the right-hand side? 0. So my slope is 0. Look, I'm at this point right here. You just look at it, right? If I'm at this point right here, what does the tangent line look like? A horizontal line, which has a slope of 0. This point is 0, -2. So the y-intercept is -2. Y equals -2. Done. You don't have to do any calculus. Well, you have to know that that's what it means for the calculus. Okay, I have time. Number 9. That was our last one, right? I have time, but no space. Let me put it in. Get that little snipper dude out again. Number 9. XY cotangent XY. Man, I need the product rule on both sides of this guy. Yeah, okay. So the derivative of the left side is 1 times y plus x dy dx equals, what's the derivative of cotangent? Negative cosecant squared. The inside function doesn't change, right? Times, I need some big parentheses here because to take the derivative of this inside piece, I need the product rule. Yeah, but look, the inside piece is the same thing as the left side. I already did the derivative of that. So this, remember the problem we did before where this guy on the right-hand side, this cosecant squared is attached to this term that doesn't have dy dx and this term that does have dy dx. So before I can move all the dy dx's to the left, I need to distribute that guy because he goes with one that doesn't have him and one that does have him. So the left side looks like 1 times y is y, x dy dx equals, I'm going to distribute this guy here and here. He's negative, so I have negative y cosecant squared xy minus x cosecant squared xy dy dx. I'm gonna leave it there. I know you can do it now. Bring this guy, the dy dx term to the left. Bring this guy, the y term to the right. Factor out your dy dx and divide by all the gobbledygook. Okay.